This video is a direct follow-up of the previous one, so if you haven't watched the video on struct basics, please pause right now and go back and check it out first, okay? Because we're going to really build on it. What I have right now on my screen is pretty much a code that we wrote in the previous video, and we are going to use this as a starting point and modify it to introduce a new concept, the concept of union. So, union is the first, at the most primary level. Union is a keyword in the C language, right, that you use where you would use the keyword struct. So it has a very similar syntax, okay? Union, my data, open curly brace, close curly brace, and a list of fields, like so. So when you do the type def, you do type def union my data, and you call it my data, and then after that you can use the data type my data or union my data everywhere you would use a regular data type. So that means parameters, local variable, global variable, and so on and so forth, okay? In terms of differences, because all of this is the same, right? The same thing for the dot notation, the arrow notation, everything is the same than structure, except for one big, huge difference. A structure, let's grab like the whiteboard real quick so that I can show you visually what I mean. A structure, like we had my data, okay? When you have a variable data1, that variable data1 as a structure contains multiple fields. For example, in our example, we had a field named value, okay, and a field named dValue. And it's pretty clear, even though I didn't make it explicit in the previous video, it's pretty clear that it's the combination of those two fields that constitute one of your structure my data, okay? It's so obvious that it's kind of difficult to explain it without making it sound confusing, okay? If I store 42 and 42.9, I store 42 in this first field, I store 42.9 in this other field. So how could it be possibly different than this? Well, let's say that now we redefine, so this was last video, right, when we were focusing on struct. Now we're focusing on union, and I redefine the data type my data as a union my underscore data. And when I declare a variable data1 of that type, okay, here's what happens. It's smaller. So where is value? Here. Where is dValue? Also here. What do I mean? Well, I mean that there is one space of memory that has been allocated, and the size of this chunk of memory is the max between the size of value, the field value, and the size of the field dValue. Meaning value is an int, dValue is a double, so the size of this is the size of a double. Does that make sense? The idea is you take the biggest of the two fields. If you have three fields, an int, a double, and a long, you take the biggest of the three. If you have 5 fields, the biggest of the 5. And that's how much memory you get. Why? Because unlike a structure, a union goal is not to store all the value for all the fields. A union goal is to say, I'm going to have a chunk of memory, and you may use this chunk of memory as an int value, or, and this is an exclusive or, you may use this chunk as memory as, for example, the double dValue, and so on and so forth. So when you are listing here, maybe if I don't use the tablet, the mouse will be reacting better. There we go. When you are listing a bunch of fields here, it's not that you want value and dValue to be inside your structure. No, you want a union that's going to contain value or dValue, one at a time. Okay, so you are allocating enough space to all the biggest of the two, the double, and when you're using that union to access dValue, you're using the whole space. When you're using this union to access only the field value, you're using a fraction of the space that you allocated for the union, because an int is smaller than a double. Okay? Let me show you in practical application what this means. Okay? So we have here some code that assigns a value and a d-value to data 1. Well, first, you know what? We're going to take this code and run it with a union to show you exactly what's happening. Okay? A little weird. So display data 1. Data 1 contains 42 and 42.23. That's not a 42. That is 42.23. That's correct. So what's happening here? Same thing here. The second time I display data 2. It should contain 999 and 999.9. Well, it looks like the first field is garbage, and the second field only is what we store accurately, right? Well, kinda, but if I change the order here, if I assign 42.3 and then I assign 42, let's take a look at if this changes anything. So GCC, a.out. Well, yes, it changes things quite a bit, okay? So now 42 is stored accurately, but 42.229980, etc., there's something weird here. I didn't store 42.23 accurately here, okay? So what's going on with this? Well, we overwrite the memory, meaning that, and let's go back to the whiteboard to show you exactly what's happening, meaning that when I assign 42, I assign 42 using most of the space here. Oops, wrong pencil. There we go. And when I assign 42.23, I override this and write 42.23. So in the space of a union, okay, if you have all the space for a double and all the space here for the int part of it, writing 42 writes here, writing 42.23 uses the entirety of the space. But if I rewrite 99 on top of it, you realize that I have been corrupting pretty much all the bits that I was using previously to encode 42.23. So the rule with union is you can have as many fields as you want. You can use all of the fields, but you have to discipline yourself. You have to police yourself so that you use only one field in a meaningful way at a time. For example, let's go back to this code, and now we are going to go towards some code that makes more sense for a union, okay? I'm going to keep my type, my data, etc. I'm going to keep the display for now. I'm going to get rid of the compare because we're not yet there. I'm going to create my data 1, my data 2, yes. I'm not going to compare them. All of this, the access with pointers notation is the same as struct, so I don't need to illustrate it. I'm going to keep just my code simple here, and I'm going to this time not try to use my union the same way I used the struct before, but use the union as it should be used, okay? Which means what? Which means that data 1, for example, I'm going to use it to store a double. So I use the one field in the union that allows me to store a double. And when I display, I'm going to display both fields of the union, but they both look at the same piece of memory. So the field that corresponds to the double is going to make sense, but the field that corresponds to the int is going to look at just a few bytes, a subset of what is in that chunk of memory, and that's not going to make sense. This is why we get garbage. We get those weird minus 15461888227 numbers, right? So the second variable, I'm going to do the opposite. I'm going to use the field inside of it that corresponds to an int, and I'm going to use, and I'm going to display both, and I'm going to see that only the field that corresponds to an int makes sense. Let's save that, and let's try it. So recompile. There we go. Run it. First one, I use the double part, it's there. The int part doesn't make sense. Second one, I use the int part, it's there. The double part doesn't make sense. And that's what union are meant to be used for. They are meant to be used as that variable can contain an int or a double. Here is the name of the field to access it as an int. Here's the name of the field to access it as a double. But if you try to use both at the same time, like for example here I try to display both at the same time, one of them is not going to make sense. Only the one that you assigned previously, assigned last, pretty much, is going to actually hold this value that makes sense, like 42.23 or 999. What could possibly be the use of this? Every semester when I introduce this, the most question I get is, I kind of understand the mechanics, but I don't see why I would bother with this kind of stuff. So let me try to anticipate that question. Let's say that we're going to mix together union and struct, okay? Let's say that we have here a structure, so struct, variable data. And inside the variable data, I'm going to have a char star name of the variable. And then I'm going to have a value for the variable. So I'm going to use that structure to keep track of variables that I use in a programming language or in a program that I wrote, okay? So I want their name and I want their data type and I want their value. So the data type, I'm going to store it as a string, just to make things simpler. Data type, okay? And then the value, well, the value is an issue, right? How am I going to store the value? If my variable is of type, let's say, integer, I want to store it as an int. If it's of type floating point number, I want to store it as a double, maybe. So this field value may have different data type, pretty much, right? Well, this is where we're going to use union, okay? We're going to call this union numerical value, and we call the field value. So what is my union numerical value going to look like? Let's define it here. Union numerical value. Okay, and we are going to call the first field I value for int value, and the second one D value for double value. Okay, so here we go. When I have a variable of type numerical value, okay, I know that it can be used as an int or a double depending on what field inside of it I'm using right now, I value or D value. So I can type def my union numerical value into a type name that's shorter, like num value, okay? And then I can use here, instead of union numerical value, I can use num value. And similarly, I can type def struct variable data, and I'm going to call it var data, okay? All right, so now I have a way, and I'm going to get rid of that momentarily, okay? Now I have a way to represent things like this. For example, I can say var data variable number one, okay? And then I can say variable number one dot name equals number of players for game that I'm writing, for example. Variable one dot data type. So I'm not going to use the data type from the C language. I'm going to say that I'm writing here a piece of code that tracks variables in a program written in another language where, for example, I have data types such as integer, okay, just so that we don't confuse a thing int in between strings, quote, double quotes, and stuff like that, right? So var1 dot data type equal integer, and then var1 dot value, and this is where I am able to choose. I'm able to choose, okay, since the data type is integer, I choose to represent the value as an int. Do I have an int? Yes, I have an int called iValue inside the union. So I'm going to say dot iValue equals and whatever value I want here. Okay? So this would be a way for me to actually represent a structure with a union inside, and I need to correct a few things here. So it's before struct, Where did I forget semicolons here? 19 point. Yes, I forgot the semicolon right here. There we go. So let me fix that little typo first. GCC again. There we go. So what I have now is I have the capability to use a struct that contains two fields, and those two fields are always there, okay, plus a third field. And that third field itself contains, because it's a union, two fields that I can use in alternation. When I need the integer, when I need to use value as an int, I use .i value. When I need to use value as a double, I use .d value, okay? And I can use that to store, for example, the first variable like so, and then a second variable where I'm going to use something different, okay? var2 dot name equal, for example, score. var2 dot data type equals, I'm going to say it's a floating point number, okay? So the name integer and floating point number, once again, I made them up, okay? I'm assuming that I'm parsing like a new programming language that I'm designing, and I'm writing the data types that I would use in that programming language, right? And then var2 dot value dot, and then now I want to store a floating point number. Well, in my case, I chose to store that as a double, so d dot d value equals 42.9, for example, okay? And when I display, so display var1, display var2, the key with union is that you are going to most likely have a if somewhere, okay? A if that's going to decide, okay, you want me to display a union, but I don't know which field you want me to display. And that information will be somewhere else. For example, here the information is stored inside those strings here and here, okay? So let's write the function display together. Void display is going to take var data, I'm going to call it v. And what we're going to say is we're going to display first printf the name of the variable. So %s, and it's going to be v.name. And then we're going to say v.name is a floating point or an integer. So %s. I'm going to display v.datatype. Okay. With value, and then I'm going to display that with another printf. Okay, so I'm leaving that ... for now. I'm going to take care of it in the next part of this function display. So right now, let's try just to do that part. Okay, let's make sure it works. So GCC out. Number of player is an integer with value, and we didn't display anything. And then we have the second print that does score is a floating point with value, and again we didn't display anything. So if I add a little print of backslash n here, it's going to make things so much easier to read on the screen. So let's do this. I forgot my SDIO. Didn't I? No, printf. Oh, print instead of printf. Sure. There we go. Up. Out. There we go. So we display the name and the data type that we recorded for that variable, right? And now we want to display the value. How are we going to display the value? Well, displaying the value is a matter of doing printf simply, v.value.iValue. That would display the int part, or printf v.value.dValue. Okay, but if I display both of them, let's save. If I display both of them, it's going to be messy, right? What did I forget again? v.value.iValue. Yeah. Printf wants a format specifier. I was using Java here again. %, so I want to display a %d here. and I want to display a percent LN here. There we go. That should make the compiler a lot happier. Let's go and check it out. There we go, run it. So this is exactly the problem that we had before, right? The problem we had before was if I try to display both fields, and I should probably make a space at least in between so that they are not all mangled together. If I try to display both fields, one makes sense, one is garbage. For example, here for the integer variable, yeah, I previously assigned the int field to 42, so that field makes sense. The floating point field, the double field, doesn't make sense. And it's the opposite for the floating point variable here. So how do I decide which one to display? Because I want to display only one of them, the one that's relevant, right? Well, I'm going to use the if statement. Okay, that's how you make choice in a programming language. So I'm going to have if, do this, else, do that. And the condition, what is it going to be based on? It's going to be based on v dot data type. So if v dot data type is the same as, so I'm going to compare the string compare, v dot data type is the same as, I'm going to hard code it, so integer. There we go. If v dot data type is the same as integer, so the str compare returns 0, then I'm displaying the integer part. Otherwise, I'm displaying the floating point part. And here I have only int and float, but I could have different types like int, float, long number, long integer or something like that, and use different fields like I value, d value, L value that's going to be a long, defined as a long, and so on and so forth, okay? So I use only 2 fields, but you could have as many fields as you want in your union. And this is going to allow me to actually make the choice dynamically at runtime and decide, well, here, because the user put in the field data type, the string integer, I know that I'm going to use only the integer field of my union. Because the user put floating point here, I know I'm going to use a double field of my union only. Okay, so this is a very powerful tool, especially when you start writing tokenizers, things like that. Programs that are going to read a file that is the source code of another program in another language, and they are going to try to identify the keyword, identify the variable name, etc. And they're going to build data structure to store information about what the program does and what you wrote in that other programming language, right? When you do stuff like that, when these features are going to really shine. Other than that, it's used, you saw me use it, it's really used the same way, syntactically speaking, than a struct. It's just that you store only one of the fields at a time. And that's it. We're going to wrap it up here for unions. As usual, if you have questions, forums, Piazza, whatever we're using this semester, or even better, come to office hours, and I'll see you in the next video.